Hi, my name is Dimitri Castiblanco, and today I will be talking about my game Atari Broken Out, made by me. The first thing we're going to do is press R to see the rules. So here's some general gameplay. You press the spacebar to release the ball at the beginning of the game, and after each time the ball dies. You control the bar on the bottom using the arrow keys. There are some power-ups in the game. The first one is the Double Trouble power-up, which adds another ball on the screen. This other ball cannot activate other power-ups. The 1-up power-up gives you another life. The object of the game is to destroy all of the blocks in the world. There might be some twists, I'll explain along the way. Good luck. And we're going to press enter to start, and then press the spacebar to release the ball. I'm going to try and get a run through right now where I actually win to show you what happens. The lives are displayed on the bottom left corner of the screen. There's our first power-up that spawned, that is the Double the Trouble power-up. You may have noticed that that ball actually died, but it didn't change our lives because, that's how I made the game. Only the red ball dying changes the number of lives. The red ball should be the main priority, as it is the one that controls the lives. Okay, now there's a lot of things to keep track of. Okay, did not mean to do that, but it's okay. So now the problem is just actually hitting the blocks. There we go. It takes a couple of cycles, but we eventually get it. Okay, still have a lot of lives left. When the red ball dies, it also removes any power-ups that are on the screen for a short time, before they are added once again later. Oh yikes. Now I'm dying a lot. But it's okay. I have enough lives to keep going. Right now I'm just getting unlucky by not hitting any of the walls. Or any of the blocks, excuse me. Just barely misses. And this should get it. Nope. There we go. That's one. Hopefully I have a lot of lives to keep going with. Should give me another one. Oh dang, I let the red ball die. See, the game seems pretty easy, but there are so many things to keep track of. That's why I'm not talking a lot. It's very stressful. I'm trying to win. Okay, just one left. That should get it? No, dang. Alright, it's okay. Oh, no, did not mean to do that. Oh, we still have a lot of lives, it's okay. Should be the last hit, hopefully. I'll explain what I mean by that in a second. Still got a lot of lives, it's okay. That should get it. Yes. Okay, great. We won, and that's exactly what happens if we win. So I'm going to reset it, and I want to show what happens when you run out of lives. So I'm going to press enter to start, and I'm just going to let the lives run out. And you'll see what happens. Yep, and that's the game over your screen you get if you lose. So the next thing I'm going to show is a class by class kind of explanation of what's actually going on in this game. Okay, so here I'm going to explain class by class what is going on. So right here, the way I'm recording this, I have to have all of them open so I can just swap to them. But we're going to go class by class in the order that it was in the beginning. So the first thing is my world, which extends world, as you could have seen in the side. The first thing we have here is an array of the names of the block colors. And then in the constructor, it just sets up the world and calls two methods. The block spawn method, which just, which adds all of the blocks the correct distance apart and the correct type. So you have the blue blocks, the green blocks, the yellow blocks, and etc. And I'll explain that later. And then you have the populate method, which just adds the bar, the ball, and then the power up, a power up which goes. Whoops, did not mean to do that. A power up which goes in the bottom right, and then a text which goes in the bottom left. And yeah, that's what's going on there. And then it also adds a title screen, which we saw at the beginning. In the My World constructor, it also sets the ball lives to 3, and since this is static, it can actually do that. And that kind of avoids what was happening before, was when I would reset it, that static lives wouldn't change, so it would always give me the game over screen because it would be at 0 lives. So what this does is keep that from happening every single time you reset the world. But yeah, that's My World. And then we have the ball class, which is definitely the most confusing and the one with the most instance data and methods. So ball extends actor, as always. So you have a couple of booleans here. We have up, down, left, right, and then ball release. Then we have a static integer, which is the number of lives, and then we have the music. So in the constructor, we set basically everything to false. We set everything other than right and up to true, and everything else is false because the ball, when it starts, it goes off in that direction, and it also sets the rotation for the ball to -26. In the act method, we call a variety of different methods. The order matters, but I'm not going to explain why. I'll just talk about each method independently and what actually happens. So first thing, one of the things it does is check start. So this just makes sure that the spacebar is down, and it also makes sure that there are no screens in the class. There are no screen classes or screen objects on the world. So this returns a list of screen objects, and if there are none when it's equal to 0, then it can release the ball, because before it was releasing the ball before the screen was even gone. We have our music method, which really just keeps the music playing as long as the game over screen is not on there. If it is, then it returns a list, and if there is something in that list of objects in the game over class, then it will stop the music and then play a different type of music. So here I have my move method, which I actually got from online from a person called Retro Burger. I have him linked right here to the user. So he created basically a game very similar to mine, and I used his move method because it worked really well. I changed a couple of things, but the majority of it comes from Retro Burger. I'm not going to try and explain what happens here. It's just a lot of logic, and so this checks if it's hitting the right wall, left wall, and etc. The only thing I'll explain is at the bottom. So at the bottom, what it does is set wall release to false, which makes the ball not launch again when it resets. So then it calls a reset method, which I'll explain right here. And the reset method, what it does is set the transparency to 0 of the original ball, of the red ball. So that ball is no longer able to be seen. Then it changes the location and then resets the transparency and then resets the rotation. So that's what happens there. And then it also subtracts a live. And right here it just checks if there are objects of the double trouble class, or if there are objects of the 1-up class, then remove them as well. It removes the entire list of objects if there are any. Then we go back here after the reset method, and what this does is it gets all of the objects of the second ball class. So if there are second ball objects on the world, it will remove that whole list of objects, which is what I was explaining during the gameplay. Next we have the bar class, and this also comes from Retro Burger, same link. And all it does is really just programmatically explain what's happening when it hits the paddle or the bar on the bottom. Then we have the block method, which is probably the most confusing method on here. It also comes from Retro Burger, except for this first part. I actually had to do this first part, and it's very confusing, so I'll try and explain what's going on. I would say this is one of the special things I had to do to make this actually work. So what happens first is it makes sure that the ball is touching a block object. Then it creates a local integer x and sets it equal to 0. Then we go through a for loop of a list of all of the objects of the block class inside of the world. And if that specific object, I get it using get I, is an instance of block, which they all should be, then it will set block B, cast the block that we're getting from here, whichever kind of block it is, it will cast it as a big block because the block is the parent class of all of the colored block classes. And that's what happens first. And then it rechecks to make sure it's the same block that was touching the ball from before. So if that B is touching ball class, this method is overridden. I got it from, we'll talk about it later, but it's in the block class down here somewhere. It's in the block class. I had to override it in order to be able to use it inside of this class. But that's basically what's happening there. Then it subtracts a hit, which is also in the block class, and then it sets that local integer to that number of hits. And then here it basically does the same thing as move, except it removes the block class if x is equal to 0. So certain blocks have a different number of hits, but I'll talk about that later. The power method also just makes sure that they're touching, and it plays the correct audio. And then if it is touching one of the power-ups, it just removes it and then adds. For the double trouble, it will add a second ball, and then for the one-up class, for the one-up power-up, it just adds another live. We have a static get lives method because lives is static, and I have to use that when I'm doing the text method, which is the last one I'll talk about. But yeah, that's why that's in there. And then we also have a check lives method, which basically just checks if the game is going to keep going. If the lives is equal to 0, then it will add the game over screen and play the game over music. And then lastly, we have the check end method, which basically just makes which checks if there are any block objects in the world. If there are no block objects, if the list has no objects of the block class in it, then it adds the winner screen and plays the victory music, which is also what we saw. Next, we have the second ball, which extends the first ball class. It is actually a child. You may have seen it on the side. It extends ball. And so it has no constructor. It uses the parent's constructor and sets all of those booleans to the same values. The only things that are different are the classes that are called in act. So there are a ton of there are a ton of methods called in this act, but in the second ball, since it really doesn't do much except hit the blocks and the bar, it only calls the block and the bar method, which are both in the parent class of ball, and it calls the move method. But I had to override the move method from the ball class to make sure that when it hit the bottom, it would just remove the object. And it doesn't change the lives or anything. It just removes the object. That's the only difference of the move method. And that's why I had to override it for the second ball. Next, we have the bar method, which just has a move method in it. And it just changes based on the arrow keys. That's all that happens in the bar class. Next, we have the block class, which is a little bit confusing. So in the block class, it has a private integer num hits, which changes based on what's going on in the ball class. The constructor just has a string type color, or excuse me, a string that is called color, and then it sets the image to that color. Basically going back right here. So all of these constructors of their certain colors, but in each one individually is just the same constructor. It calls the constructor from the superclass for this of block, and then it sets the color to that. That's the only way I could do it. That's the way that made the most sense to me. And then we have this overridden is touching method. So it's just called is touching, and it takes a parameters class is what I called it, because if this is lowercase class, it does not work. And what it basically does is call the normal is touching method on that class, but since I can't do it in the method itself, so I had to override it. And it returns a boolean. And then we have a set num hits in the block method as well. And it is what each of these use. So that's what I was talking about before. I don't know if I mentioned it or not. But the blue block took 1 hit, green block took 2 hits, yellow block took 3 hits, orange block took 4 hits, and then the red block took 5 hits. And that's all I'm going to say about those, because they all call the super constructor from the block class, and that's why I had to use inheritance there. It just made it was the easiest way to do it. And since I have that block class as a super class to all of them, I can use that to call a list of all the block class objects, since all of the colored blocks are still blocks. It's the easiest way to do it. Here is the next big class. Here we have the power up class, which doesn't actually ever appear, and this is what is being added at the beginning in the my world. So what it does is adds this thing right here at the top. It's like from the card game. It puts it at the bottom. Since it's black, it was the easiest way to do it. So it's always on the world, but you don't see it because the background is black. That's the way I had to do it. So it has a private integer counter that starts at 0, and then in the act method, it makes sure that there are no objects of the type screen in there. So if it is equal to 0, it will continually add to the counter and call the add method. And in that add method, it basically uses some math to randomly add certain power-ups. So for for the double trouble method, it adds it if it's every 750 seconds or however many times the counter adds. And it's just at random locations in a specific range. And the same thing with the 1-up power-up, except it's added not as many times. It's not added as many times. And that's that for the power-up class. The kind of trick I had to use there's nothing special about it, but the easiest way to do it was kind of blend it in with the background, so it could always be there and it would always be calling the act method. And then in the double trouble and the 1-up class, they don't have anything in them at all. They just have certain images, which is the important part, and that's it. Same with the screens class. I made a super class for the screens, for all of the screens, and it's really only to make sure that there are no screens on there. It's the easiest way to do it. Instead of making a class for every single screen, they are all just subclasses of the screens class, so I can call a list of all of the screen objects, and they are all included. Game over is just an image. The rule screen is also just an image. The windscreen is an image. The title screen is really the only thing that has methods in it. So it has no instance data, but in the act method, it calls the add more screens method and the remove screens method. So in the add more screens method, it checks to see if the key is down, if the key R is down, which adds a new rule screen method, image class object, a rule screen object, which is really just an image that takes up all of the space on the screen in my world. And then it also calls a remove screens method. So if the key is down, if the enter key is down, then it removes any objects. So actually, the first thing it does is get a list of rule class objects and make sure, and if that list is greater than 0 and that rule class is not null, then it will remove the objects of get world of the rule screen. If not, that's okay. If there's no rule screen, that means that the person didn't want to see the rules, and you can just press enter and start playing, which removes the object this. And I had to put that at the end because if I had put it at the beginning, then the class would not exist anymore. So that's my workaround for there. And then the last method here on my class in my game is the text method, which has a private string called lives. And in the act method, it calls two methods: the set lives method, and the display method. So in the set lives method, it sets the string lives equal to string lives colon plus ball.getLives, and this is where that static method basically is very useful, because I can just say ball as in the class and then the getLives method, and that's the great thing about the static method. I can just call it from here and I don't have to specify what ball I'm talking about, since there really is only one on the screen. And it sets that. And then in the display method, it's always called, so as long as there are no screens on the method, on the world, which is what I'm checking here, returning a list, as long as that list is equal to 0, then it will show text, which is a greenfoot method. It's a get world method, but it's in greenfoot, and then it will show it at that specific spot, which is in the bottom left. So those are all of the classes, and that was basically my explanation of how they represent physical objects. So obviously all the blue block, green block, orange block, red block, yellow block, the double trouble, 1-up, and the ball and the second ball, those are all classes, but they all represent physical objects, and that's basically how all of the classes interact and what is actually going on. So I hope that made sense, and I tried to explain inheritance as much as I could also. So that should cover all those bases. That was inheritance. The most of the inheritance comes from calling list of of one big type, which just grabs everything of the children. And then the biggest inheritance, the biggest use I had for inheritance was definitely in this second bulk class by overriding that and calling the constructors of the block class in all of the subclasses of the type block. And that is basically that. That is that. So next thing I'll explain is the UML diagram, which actually just simplifies what's going on. So yeah, that'll be the next thing. Alright, so here I'm going to explain my UML diagram for my game, Atari Broken Out. So originally I had done this in Excel, but I realized once I was done that my UML diagram was not up to par with anything I had done. So I decided to redo it on Lucidchart, and that's what I have here. So we have our two main classes, obviously World and Actor. I'm going to explain World first. So World has a subclass, a child called My World, which basically only has one instance data that's private, and that's an array of strings, and it's called blocks. And we also have two public methods called populate and block spawn, which I explained earlier. Next, we have the ball class, which is a child of the actor class. So in the ball class, all of the instance data is public, and I'll explain why in a second. And the majority of them are booleans, except for lives, which is static, and that's why it's underlined, and it's also an integer. It has a lot of methods, which I explained earlier, and they all return void except for getLives, which is also static, and that's why it's underlined, and that returns an integer. Next, we have the second ball class, which is a child of the ball class, and it has two methods, the act method, as all classes do, and it has the move method, which it's overriding from the ball class, and that's why it basically inherits all of those methods, but the only ones it uses in the act method are the bar and the block methods from the ball class, and then it uses the move method. And the reason the instance data in the ball class is public is because in that move method, in the second ball, it actually uses some of this instance data, and that's why it's private. It's the easiest way to get to it without having to make getters and setters for every single one. And then next we have the bar class, which is also a child of actor, and it only has the act method, which returns void, and the move method, its specific move method, which also returns void, and that just controls the directions it's going in. Next, we have the block class, which is also a child of actor, and it has one instance data, and it's private, and it's an integer called numHits. It also has 4 public methods. The first one is touching, which takes a class as a parameter and returns a boolean, and it's just I'm overriding the isTouching method from the actor class. And then it also has a setNumHits method, which has an integer as a parameter and returns void, a getNumHits, which returns an integer and has no parameters, and then a subtractHit method, which is also void. Then we have the colors of the blocks, and they are all subclasses to the block class. And the only thing that makes them special is all of their constructors have one different value in each of them, but the constructors of each of these the first thing that they do is call the superconstructor from the block class. They call the constructor in the block class, and that's why these are justified as subclasses. Next, we have the power up class, which has a private instance data. It's called counter, and it's an integer. It also has 2 public methods, the act method, which returns void, and the add method, which also returns void. And the add method is the one that controls when these 2 power-ups randomly spawn. And the only thing special about these two and what makes them subclasses to power up is the images, but there's no code inside of them. It really is just the images that matter. Next, we have the screens class, which has 4 children, and screens is also a child of actor. It has 4 children: the win screen, game over screen, rule screen, and title screen. Win screen to rule screen and game over screen, they're all images, and they don't have anything special inside of them. And then we have title screen, which does have 3 public methods. It has the act method, as all the other classes do. And it has a public add more screens method, which returns void, and remove screens method, which also returns void. And we use these for adding all of these other screens. And the only reason these are children of the screens method is because the easiest way to grab and make sure there are no screens on the screen, no screens in the world, is to make sure that there are no screen objects. And since these are all screen objects, that's the best way to do it. And lastly, we have the text class, and it has a private instance data, lives, which is of type string, and 3 public methods: the act method, the set lives method, and the display method, which all return void. And that is the UML diagram for my class. I hope that made it easier to understand. The last thing I'm going to talk about is some bugs, and yeah, that'll be it. Okay, lastly, I'm going to talk a little bit about some bugs. Okay, so one of the ones I know about is that occasionally, if the ball will go through the block like this, because there was no easy way to get it to go back up, not programmatically at least, because it would just mess up so many other things. Another bug I know of is that occasionally the ball will bounce off the wall and does something like this, and will travel along like touching 2 blocks at once. And this really messes up the program sometimes. It makes it impossible to break that block ever again. Because what I was explaining in the ball class, in the block method, when it's kind of casting and making sure it knows which one it's touching, since it's touching 2, that really just breaks it. And so whenever it hits it again, it doesn't break correctly. And those are really the only 2 main bugs. The last one is kind of minor, and I'm not really sure how to stop it, but it happens every once in a while. The ball will just literally go through. It really only happens when it's at the edge. Sometimes you just go straight through and you lose that 1 life, but it's okay. It doesn't happen a lot. For some of that special features, I would definitely say that was casting and going through a for loop of all of the block objects. That was definitely the hardest part of this whole entire project. But I would say that was like that's the coolest thing I had to do, because it's so hard to specify one block that you're talking about when you have 25 options. So I think getting that to work was really cool. And then I already cited some of that third-party code I used. Retro Burger, he came up with a lot of the move method and the block method, or excuse me, not the block method, and the bar method, which really helped me out. And I kind of used that as a base and went on from there. And now the game has flourished into something else. So yeah, definitely, I would say that this project was a challenge, a very big challenge at times. A lot of 2 or 3 hours just sitting there not sure what to do. You look it up and then it's just 1 line of code. That it was that simple. Definitely a little frustrating at times, but it really helped me understand, I think, how object-based programming is, because here we actually see physical objects. It's not like in BlueJ when we're just writing. You don't actually see the object you're working with. Here we actually see it, so it helps me understand what object-based programming really is a little bit more. The fun level, I would say, now that I got it to work and I actually basically understand everything that I'm doing in the program, I feel it's really fun actually getting to the point where you do something complicated, but you actually understand what's happening. That's really cool for me, and I'm really happy that I learned how to do this. So I would say for my final project, even though I didn't do everything I wanted to do, I think I learned a ton, and everything I did was worthwhile. I really enjoyed all of it. And yeah, even if I wasn't able to do everything, like, this was a lot of work and it was difficult to get it done. So I'm pretty happy with where it is now and what's going on. Definitely what I learned is there are a lot of things that I learned. A lot of it is Greenfoot based, what I've learned, but I'll talk about a little bit about it. So you can remove entire lists. I didn't know you could do that. So when I was talking about like getting all of the second ball objects and removing that whole entire list of second ball objects, that was completely new for me. I didn't know you could do something like that. Just remove everything in a list. So that's pretty cool. And I would say it's learning how to remove things that may or may not be there. So that's a lot of logic. Having to say something like, oh, if a list of this kind of objects from this kind of class is equal to 0, then it's not equal to 0, then remove that, then remove all of them. That was really weird. I didn't know you could do stuff like that. But now that I do, I feel like I could program another game. It would be easier to program another game. And even though my game doesn't really involve like a character moving, it was still a lot of work to program all of that, all of the physics and all of that specific ball and block things that are going on, including the power-ups. Those were confusing at times as well. But overall, I would say that this project was very fun. I learned a lot, and I'm very proud that I created something this tangible and that works like this. So thank you for watching, and I hope you enjoyed my video.